Hello, everybody. This is Tony. Who else would it be? Just gonna continue with the exam 3 review. I extended the PowerPoint, I think, by 15 slides or something. Some of them have notes underneath. Please, if you see a note, read it. It's to be helpful. And let's try to continue where we left off. I added some pictures. Okay, so we were here during lab. I made this slide, and I'm going to be continuing from here. I want to correct myself for something I had said before about between groups and within groups. I had said that within groups was like pre-test and post-test, but after reading your textbook, it says otherwise. So behind that, the book is saying that in between groups, pre-test and post-test is not considered within because your participants are only being exposed to one condition versus your within groups, your participants are being exposed to multiple conditions. So just wanted to start off by clearing that up. Experimental designs. We have our simple experimental design, one IV and one DV, where one variable is being manipulated and the other one is being measured. For factorial, we have two IVs or more and two levels or more and one DV or more. But when there's multiple DVs, that's when we get into the like multivariate statistics and latent variable and stuff like that. So I'm not going to go too deeply into that. Quasi-experimental designs, it does not have full experimental control, is the basic gist of what your textbook is saying. Continuing on. Before I continue, actually, I have Juan's PowerPoint available. He's allowing me to share it with you guys, so thank you, Juan. He has a lot of information in there about how you can collect participants and hopefully you can connect that with experimental designs, conceptually integrate them together. You'll know what I'm talking about later. Okay, so this slide, we're going to talk about confounding variables. One cause that can result in confounding variables is unequal properties of your research. For example, you have significantly different amount of participants per group, you don't define your variables clearly, or you're not being consistent with the steps of the experimental design. We also have history effects, practice effects, maturation effects, and you can go to chapter 11 if you'd like to find different threats to internal validity. So with history effect, this occurs when your participants have experienced an event that not everyone has experienced. So if you're trying to do a research on how many funny movies people like to watch a year, and then you see that this group of people that you collected, and just by random freak accident, most of your participants are people who took a famous happiness workshop or something like that. So that those group of people are going to be confounding variables because, let's say for example, if you go to this happiness workshop and you get really happy, and you decide to watch more happy movies, then that's a biased sample right there. So that's one potential cause. Practice effects occurs when someone might take a test multiple times, and you can control for practice effects by spacing out when your participant takes a test, or you can mix up the questions that you administer, just as long as these questions are related to the construct. For maturation effects, that's that's basically what occurs when, let's say, you have an IQ test or something at 10 years old, and then again, this is a hypothetical example. So let's say you get a 115 at 10 years old, and then and this is at the beginning of the school year, so September, right? After a few months of education, that child's IQ um, might have increased because he learned more. So if he went up to 120 or something within those few months, it could be that he learned a lot more stuff that helped increase his score. So I'm starting from chapter 1, y'all. This is going to be your semester long review and hopefully less than an hour. So I took the most, I don't want to say basic, but I took the most commonly seen points from your chapters. So if you need examples and more information, please go ahead and refer to your textbook. But in psychology, we have producers and consumers, and as producers, people rely on us, so we must report reliable findings accurately. And consumers were tended to be attacked by all these findings, and a lot of the interpretations are incorrect, so it's important to know that. What makes a scientific theory good? It's supported by data, can be falsified, and parsimony. So again, parsimony, it just refers to if there's two definitions, the simpler definition is preferred, the easier one to understand. So for example, natural selection, right? We have Darwin, and I forgot the other guy who came up with his own natural evolution theory. But you can tell that we no longer follow that theory because Darwin's theory was a lot easier to understand for a lot of people. Saying that theories can be proven is incorrect. As you may know, hopefully you've learned by now, we rarely get to say that, in psychology at least. Chapter 1 continued. Applied research versus basic research. Basically, knowing this question, what's the purpose of the study, knowing the answer to that question will make your life easy. So, are we trying just to increase the knowledge about some construct, or are we trying to help solve a problem that affects a lot of people or that affects certain populations? Okay, chapter 2, research is greater than experience. Experience can only tell you so much about the things that are occurring around us. And research is a million times greater than intuition. Don't listen to your gut unless it's yelling at you to occupy its internal space with food, much like Patrick when he's mad. What are the parts of a peer-reviewed article? We have our abstract, intro, method, results, discussion, references. And obviously there are more parts, but this is the basic skeleton of a peer-reviewed article. You know what? I don't think I'm just going to read that. You can read that, guys. I'll leave that there for you. Chapter 3. I'm not going to go over this entire thing, but this table is basically what Chapter 3 is about, but obviously with more examples and clearer definitions and explanations. So go ahead and refer to that chapter if you need additional help. Okay, Chapter 5. We have conceptual variables, which are also known as conceptual definitions or constructs. We have operational definitions, which are also known as operational variables. For types of measures, we have self-report, observational and physiological measures, and examples would include surveys and questionnaires, being a creeper, just kidding, and fMRI scans during an activity. Like, for example, a really simple activity you can do you're while you're in a MRI is like finger tapping or something. The rate at which you tap your finger under a certain amount of time. We have categorical versus quantitative variables. In your book, it says categorical variables are nominal, and quantitative variables refer to ordinal, interval, and ratio scales. Types of reliability, we have our test-retest, iterator, and internal. Test-retest means that if a participant were to take some test, would they get a similar score the next time they take it if maturation effects didn't play a role, or history effects, or whatever. Iterator reliability refers to two raters agreeing on what they're observing, for example. So if a kid is playing with a basketball, I'm going to say this kid is playing with a basketball. And another person who's observing is going to say this kid is playing with a basketball. So that would be high iterator reliability. The observations are the same, or the outcomes are understood the same way by two researchers. Internal reliability. I kind of struggle with explaining this one, but I can give me just a couple minutes to try to think of an easier way to identify that. Okay, so internal reliability is kind of like, let's say you answer questions in a certain way, and if there's a pattern, that pattern should be consistent no matter how the questions are worded or phrased or whatever. So that would be internal reliability. For validity, we have face, content, criterion, convergent, and discriminant. Face validity is, does it look like a good measure? Content validity is like, are these questions representative of what we're trying to examine? And criterion validity, for that, this one's a little hard for me to define as well, but criterion validity looks at the measure and looks at the measure of a scale, for example, and tries to see if it's related to some tangible outcome. So your book over here says it should be related to, or related to the theory that's being tested. So if you need some examples, that'll be in your book. Convergent, I've spoken with you guys about this, and it appeared to me that you guys really understood this very quickly, but I'll just go over it again. Convergent validity is when you have your two scales about happiness being highly correlated. So these two scales are measuring the same construct, which is happiness, and that should have a high correlation if they created the questions or worded the questions correctly. Discriminant validity, I just wanted to make a correction also. I made a mistake when explaining this to you guys. Some of you might have seen the confusion in my face when I was looking at the results from the reliability validity assignment. So I want to go back. I left a note here, but I want to go back to the data and the output. So last time I had said there's good discriminant validity between introversion and the average comedic score. Um, what discriminant validity really is that um, two scales measuring different things shouldn't have any correlation. So it would be closer to zero, basically. But in here for the assignment, um, I realized something that the average comedic score should be inversely related to introversion. So that means, like in terms of introversion and um, comedic ability depends on whether or not you're social. So the fact that this correlation is significant makes sense. Um, but if we, for example, tried to correlate average comedic score and um, average score of, let's see, of organizing ability or something, that shouldn't have a really significant correlation in either direction. It should be closer to zero. R should be closer to zero. Um, or for another example, your scale um, on how well you know computer coding should not correlate at all with the scale about how well you know or how much of a fan you are of Quentin Tarantino movies. So, just wanted to clear that up, and we will continue with our PowerPoint. Okay. So, Chapter 6. Leading questions. You want to always avoid leading questions if you want to have reliable results. Leading questions would be like, I don't know, wasn't that first episode of Game of Thrones sick? That's a leading question. To avoid leading questions, you can simply just change it to how do you feel about Game of Thrones? Or how do you feel about the first episode? And you can tell the huge difference between the first question I ask and the question that I just asked. So, that's always good to know. For double-barreled questions, it asks two questions in one. So let me try to think of an example. Kind of struggling with creating an example for this one. So think of it this way. I think your book would be better at explaining the definition for double-barreled questions. Or not the definition, to give you an example of one. Negative worded questions or negatively worded questions, that always, not always, but it confuses some people. For me, negative worded questions are confusing, especially if they're double negatives. I struggle with those. So if researchers had questions like that, the results will less likely be reliable. It'll less likely be reliable for us to make a accurate interpretation. Question order also can affect the results and your interpretation. So, for example, if you ask, this is a silly example, but let's say, do you like chocolate ice cream is the first question, and then the second one is, do you like ice cream? Well, yeah, of course. If they said yes to the first one, then they're obviously going to like ice cream, so why would you ask it the other way around? First you would say, do you like ice cream? And if they say yes, then you would ask, do you like chocolate ice cream? But as you notice, I just created a leading question. So you can say, which kind of ice cream do you like? Trying to get accurate responses is difficult, but it is possible. And as I noted here, question order, the type of question, how you word it, etc., can affect the accuracy of the response. Questions should be ordered in a way that will allow you to figure out which participants are just blowing through your survey or being dishonest, etc. An example of inaccurate response or input would be rate my professor. And I'll kind of show you why. As you can see here, these were the first 6 teachers, I believe, in the accounting department, if I remember correctly. As you can see, there are 130 ratings for Professor Weiss, and you know, if your average college student, freshman student, didn't know much about psychology and inaccurate input or unreliable information, they would believe something like, oh, this professor has a happy face next to his name. That should be a good professor. But you see the professor has a 3.8, which isn't bad. But normally I myself would associate a happy face with something that's like 4.0 or higher, 4.5 or higher, whatever. And then if you read the ratings, you'll have some students who say, I hate this professor, the hardest of my life, wants to see you suffer, and whatever, is a sadistic professor, and and then you'll read the one that was like, that goes like, oh, I love this professor's a sweetheart, the assignments are difficult, but I've asked for help, and he made it easier for me, whatever. You see that all the time. And then for the psych department, these are the first 6 instructors. You see they're a lot higher, and even though this guy, George Law, I don't know how to say his last name, but he has a 3.5 and he has a happy face versus the instructor that I work with, Dr. Plunkett, has a 5.0 and a happy face. So, where do you draw the line of who gets a happy face and who doesn't, and if a happy face is good or not? So, like earlier up there for Professor Weiss, the 3.8, the ratings are low, but you see there's a happy face. That probably means he's doing something right, and there's some students who are bringing down his score because they weren't allowed to text or something in class or talk on the phone, whatever. So yeah, and you can see the major difference in ratings between the departments, and just overall, you can see that in the accounting department, there's way less ratings, 85, 82, 68, versus the psych department, we have like almost 300 for the first one, and then 150, 150, 130, 130. So even if you get more ratings, they'd still be unreliable, because a lot of these ratings that I've read myself didn't turn out to be true, and I did well in that instructor's class. So yeah. And when you administer these surveys or self-reports, whatever, your participants are going to respond in a way that's socially desirable. So they're faking or pretending to be good, they're on their best behavior, etc. And then faking bad also occurs, where they're purposefully misbehaving, for example, or if there's some study about aggression and this person isn't really angry but is a people pleaser, this person might act aggressively when they really aren't aggressive. So that happens, but faking bad is rare and occurs less often than faking good. Chapter 6 continued. Observations tend to help us make frequency claims. reliable and valid observations I want to talk about in respect to this. You can make very reliable frequency claims if you clearly operationalize the construct that you want to examine or study. Uh, and obviously, there will be observer bias, where the researcher will just pay attention to the things that they want to see, um, or kind of disregard contrary evidence. They'll say, "But look, this person this person was able to fall from the Grand Canyon and survive. I should be able to as well," or something. That's a silly example, so don't take it seriously. Observer effects. I want you to think about how this relates to socially desirable responding. So, in observer effects, it's kind of like participants behave differently because they know they're being watched. Um, so there are some ways to prevent observer bias and observer effects. You could have like double-blind studies where the researchers don't know who's getting what condition. Only the person who's running the research, like the first author of that study, is the one who knows. I think there's such thing as a triple blind, but I haven't really heard of it that often. Um, so yeah, double blind is a good way to avoid that. Observer bias, again, if you clearly operationalize a construct or define something very specifically, that can reduce bias. As for observer effects, doing those two-way mirrors or windows where if you turn on the light, they can see on the other side, but if you leave the light off, it looks like a mirror. Um, that's a good way to observe somebody, but obviously you can't put one of those windows at the park. Um, so what you would do is just like try to observe people. For example, at the doctor's office, like let's say there's one of those mirrors, and you can have a really great view of what naturally or as close to naturally occurs inside a doctor's office. You see the doctor will come check out the symptoms. Depending on the patient, they might or might not freak out. They might or might not start having anxiety, etc., etc. But if you're in the room observing, a participant might want to act bold or courageous or whatever, saying like, "I don't get scared of the needle," and then they pass out right after they draw the blood. So yeah, having that two-way mirror is helpful. Reactivity. I also want you to try to relate this to socially desirable responding. However, reactivity can include participants who don't behave well or accordingly. Observing others ethically. To be ethical in the greatest sense with observational studies is to not report what your participants look like, and if you happen to hear their name by chance, not reporting that name. You're basically not reporting anything of your participants except for the observations you make. So you would just say a female participant saw somebody litter, so she went and picked it up and threw it away in its proper receptacle. So that's very, very mysterious with who you're observing versus saying, "Oh, this male participant, whose name I happen to hear, Tony, with black hair, big beard, and bluish gray eyes, picked up the trash and instead threw it at the guy," or something like that. And let's say, for example, that news got published in the paper, so that would mean a lot more people from farther distances could find out about me, and then I find out that I'm in a study without consenting for my information to be reported. So You always want to be as vague as possible when you're talking about your participants. Leave no identifying information, etc. Chapter 7, um, we want studies to be generalizable. We want it to apply as well as possible to as many people as possible. Excuse me. Populations versus samples. A population is like the group of people that you want to study or have participate in your study, and a sample is just like a small collection of the people from that population. We do have biased sampling, and we can get we can get a representative sampling by using certain techniques, which have been discussed in one study guide. So now I will show you that. This is one study guide that he made available and is allowing me to share with you guys. So please go through these. They're very helpful, and he made it look very pretty. So if you don't use it, I'll be mad at you. Yeah, this is just supplemental information from what I'm teaching, but in the same way, my information will be supplemental for one student. So please take advantage of all these study guides that you're getting access to, and hopefully it'll help you do well on the exam. He also has the tests again, the analyses available on here, or images of them, for example. The t-test, we should all know by now how to write up results for that. Factorial ANOVA, that one can be a little tricky, and multiple regression can be a little tricky as well. So I'm going to try to do an example of those, a write-up. So, for example, looking at this ANOVA output, factorial ANOVA output, we see the variables field of study and proximity, and our DV is stress. If you look over here, you'll see that. So looking at the output, we're looking at the F values. We see that the field of study doesn't have a significant effect on stress, but we do see that the proximity does have a significant effect. And then the interaction of the field of study and proximity do have a significant effect on stress. So to write this up, I'm not going to get into specific details like means and stuff. One, because I don't have it available, but two, I already created examples for that a while back. So we'd start off by saying the field of study does not have a significant effect on stress. Oops. So we come in, italicize the F, get our degrees of freedom, space equals 0.174, and then our p-value equals 0.68. So going down the list, the proximity does have a significant effect on stress. Again, come in with the F, and then the degrees of freedom, and we have 5.84, and P is, P is less than, P is equal to 0.028. And then for the interaction, we have the field of study and the proximity have a significant significant effect on stress. Um, what this says about it is it's referring to the interaction, but to avoid confusion, I'll write it in both ways. So don't forget to use that PDF I created of different ways of writing interpretations. That is 5.06, and the P equals 0.039. So, copying this last part, actually, you know what, let's just copy the whole thing. The field of, the interaction between the field of study and the proximity have a significant effect on stress. So that's how you'd write up. These are the same ways of interpreting the interaction. Okay, continuing down. Oops. We're going to go to our next example. Actually, no. I want to just show you guys the R-squared real quick. So you can say the proximity, field of study, and the interaction between the two accounts for 41% of the variance. So that's from that information down here. So now, multiple regression. Okay, so we know multiple regression, its interpretation is similar to correlation. So the only difference is these standardized beta coefficients, these are like correlations when we hold these other variables constant or zero. So holding all the variables constant, we see that gender is a good predictor of VO2 max, which is volume of oxygen consumption. So yeah, and it's not saying as gender increases or something. It's depending on how gender was coded. So if zero was female and 1 was male, we'd see that males are likely to have higher VO2 max ratings than females. Or if it was the other way around, where 0 is a male and 1 is a female, then we'd say females, like of the female gender, it's predicted that the VO2 max would be higher compared to men. And then we have our sig values here. I'm not going to write all the beta outputs, but I'll just do one for example. We can say heart rate is a good predictor of VO2 max. And then we put our capital B, and then we have our beta as negative 2.52, but we're going to just write negative 2.5 or negative 0.25. And then our p-value for that is less than 0.001. Okay, so now let's go back to the slide. I just deviated a little bit, but I wanted to make sure I included an example of some write-ups. I hope I didn't get you guys off track. Okay, so picking back up, you can get an unrepresentative sample by using very biased techniques. You can do convenience sampling, which is kind of like a biased technique. It's basically you just going up to your friends and asking them to pass it to their friends, and let's say all their friends are in LA, so it's like your sample is only representative of people in LA, and also this sample's not really representative because there might be some bias. Like, we make friends with people because we agree with them on certain things, or um, we have friends because maybe, I don't know, we enjoy disagreeing. So that friend is going to pick strongly disagree and um, potentially sabotage the study. So, yeah, you want to be aware of that. Convenience sampling isn't bad. It's if you know that LA is just your area, or you want to study the population within LA, then that's totally fine. Um, but if you're trying to um, see if eating beef makes people go crazy, then just asking your friends and their friends isn't going to be representative of the whole country. So I wanted to ask you guys if you remembered external validity, um, because one, if we don't sample using probability techniques, we might not have a representative sample. So our results won't be generalizable and will then have poor external validity. So your textbook says larger samples may or may not be all inclusive, and I agree. That is, increasing the amount of participants you have doesn't make it more significant or representative of that population you're trying to study. And I want to get rid of that word significant that I just used. What I mean to say is increasing the amount of participants you have doesn't make your results generalizable to the population. And I want you guys to try to think of at least one example in which this may apply. I think I have included an example, so I will press the next button to see if I do, and I don't. Cool. Okay, so this slide, chapter 14, I just created it to kind of give you guys a direction to study in. Although I think Debbie might have given you a better direction, but I still want to do my part and kind of help you guys out with that. So if you read chapter 14, it should be helpful, but then again, it's based on certain things, so it's worth going through that chapter. In this chapter, they examine this question of can the study be replicated, and then I wrote if it can be replicated, then the results of that study can be trusted compared to a study that hasn't been able to be replicated. So always be aware of that. And I leave some notes for you with that. It's only true when the researchers trying to replicate a published study follow the steps and control for confounds almost in the same exact way that the prior researchers did. And in order to have that happen, to get the step-by-step, you're going to have to you're going to have to contact the researchers and ask for their unedited manuscript, basically the manuscript before they sent it to get published. Because as you may know, published manuscripts are a lot shorter than the first manuscript. And if you don't have all the steps, then you can't really follow it too well. And that might affect the results of this replicated study, which then would be unreliable. A meta-analysis takes the average of all the results of studies that are measuring something. So if you're trying to see if there's a study on how laughing increases or elevates your mood, or is likely to elevate your mood, if you take averages of that study and they're consistent, then you can kind of generalize that uh, you can generalize that. Sorry, I just lost my train of thought. Averaging results of false. Anyway, it'll come back to me. Meta-analyses have their strengths and weaknesses. I won't go too deeply into that. If you want to read more, go to page 422. So if you average the results of some study and the results are consistent, then you can generalize that. There you go. You can generalize that laughing is likely to elevate your mood. And meta-analysis, when I think about it, it's kind of trying to see, it's trying to see if these studies, if all these studies had the same finding or very similar findings. So I'm not saying that all these studies were replicated from one study. I'm just saying that all these studies are trying to measure the same thing in almost a similar way. So we can kind of be a little more certain about the results we're interpreting. So I believe this is the last slide. I think there might be one more. No, there's one more. Haha. External validity. Is a study generalizable? These are, by the way, questions you want to ask to see if there's good external validity. Is it generalizable? So if you take participants from all over the country by random sampling, and your study comes out significant that eating 6 cakes a day does lead to diabetes, then you can say that these results apply to a lot of people in the population. That's if your sample was randomly chosen and there weren't people from the same population by random chance. The next question would be, is this representative of a population or the population? So for this question, it's a trick, the answer to which is in your book. So if you guys would really like to check up on that, you should. How do the results apply to a population, and how many participants do we need for a representative sample? Again, this is a trick question. Read this part of the book for more information. Real-world settings. In your textbook, it asks, do studies need to be conducted in real-world settings to be able to apply to real-world situations? So some of them don't have to be conducted in real-world settings. And I provide a pretty tangible example of doing a research on people with epilepsy and exposing them to strobe lights. So is this a real-world setting? That is there something in nature that can provide us with strobe lights? Like the sun can't flicker on a flicker for us in a 30-second time span to see if it'll induce a seizure in a participant with epilepsy. So the answer to that is no, and that is why we'd have to conduct a study like this in a laboratory versus in a real-world setting. This is an artificial setting that has real-world applications, so keep that in mind. And yeah, these are deadly sins in study. You didn't randomize, accepted the alternative and extrapolated. Those last two, they're less implicit what they mean, but accepted the alternative is like think of accepting the null hypothesis when you weren't supposed to, which I think is a type 2 error. So, yeah, that is all. I hope this study is helpful for you guys, and I want to wish you all good luck. And as you see, there's a note for this slide as well. I think there's one or two more that have additional notes, so pay attention to those. And yeah, enjoy whatever is left of your Sunday. And I'm just as upset about you guys that tomorrow is Monday, but we're almost there. Okay, bye everybody.